Okay, so let's go with the documents. So we'll cover all the documents today in today's class. Okay, um, so let's go one by one. So this is business. This is called business requirement document. Okay, so this is called BRD. In short, it's called BRD. It's business requirement document. And what does it contain? It contains information about the project. Okay, it contains information about the project, what kind of is what is testing to be performed, what are the developments. Let's look at it. Okay, let's see here how does the BRD looks like. So I'll be giving you access to this Google Drive by today. Okay, so you can look into these documents and have some idea. Okay, so let's look at it. So this is located here. You can after giving you access, you can browse this directory. Okay, you'll be having access to all of this. Okay, so go to testing documents. Business requirements. Okay, so let's look at this MasterCard BRD. Okay, so this is how a requirement document looks like. Okay, it contains a lot of information. Okay, about the project. So what's the business purpose? What is the project? And what's happening in this and project requirements. Okay, what is the business requirements, and this all these are covered in this BRD document. See, the thing is, this is pretty long. This is 21 pages. Not it could be more than that. It's not necessary. It should be there. And most important thing is, it's not only for QA. Okay? So it's not just okay QA. Okay, just read it. No, this is designed keeping everyone's in the mind. Scrum Master has this access. Okay, a manager has this access. A developer has this access, and all other teams will be having access to this BRD. So they will be creating this document based on that. Okay, so you don't expect this will be a cakewalk. Just read it once and you start testing. Doesn't happen that way. Okay, that's not possible. You need to go, whichever is important, just like this here, just underline it, what is important in your project. Based on this, then you need to write your test cases. Okay, does it make sense? Does it make sense to everyone? You cannot just, okay, I know all this, and you can just start writing test cases. You cannot do that. You need to go each and everything, and first you need to look out for what is required for you to start your test cases. Okay, you need to look out here because there's a lot of information here, and it's not necessary all this information is applicable to QA point of view. Okay, this might be for project manager, this might be for developer, this might be for architect, so on. So here you need to, that's the reason, right? Just, somebody underlined it, so that means based on that, what is it important for a QA point of view, and start writing the test cases. Okay, you just can't write immediately, just looking into the document. It takes time. Okay, you need to go through the documents like 2 to 3 times or more than that. Several times you need to go through it, understand what's going on. Then you need to, but see, this BRD is more for a ETL perspective. Okay, this is more for ETL perspective, and okay, based on this, you need to write your test cases. So this is BRD. Let's go to the next one, FRD document. Okay, this is functional required document. So let's see here, functional requirement. Okay, so this is the functional requirement document, and this is how it looks like. Okay, let's say this is the requirement. All this is the requirement. No, this is not really requirement for this document, but let's compare here. Okay, let's compare and see how we can work on this. Okay, so here if you see this, there's there's like first name maps to first name field value. That means they are saying like first name, that is static text, and maps to the field value. So this is the field value. Okay, and that's what they are saying. Okay. And the similar way, the last name. Okay, there is a one more field called last name. Okay, and address. Okay, we also have this address. So what this? So this address is, this is a static value. They also want to say this is also, the field also should be tested, not the static value, that's address, but also the field value. Field value is this. Okay, whatever we type in this edit box is called field value, and state, zip, phone, the similar way what we have here. Okay, so this is what FRD. Okay, this is what FRD, functional requirement document, and it contains functionality and features of the particular application. Okay, so this is not the FRD for this website. I'm not saying this is the website that you need to do, but this is how it looks like when they prepare a document. It's not really necessary to have all the screenshots. Sometimes they don't put the screenshot, they give just simple information just like this in a document, and you need to understand based on this document and start writing your test cases. Okay, so there are few test cases here. You can look into it if you want. This is an email, and this is a few of the test cases. You can look into it, and this is the output response, how you're supposed to get once you execute this. So this is a simple requirement, simple FRD document. This is very simple. I mean, this project lasts only 1 week or something like that. Okay, so not just too long. So this is FRD document. So what is FRD? FRD is the high-level document which contains functionality and features of an application, not just web application. Here we all discussed about more about web application, but it can also contain the client application too. Okay, based on whatever the project is, that's FRD for that. Let's go to the next topic. System requirement specification, that is called SRS. Here. Yeah, system. So this is how SRS document contains. So here is the thing, right? This index itself, the table of contents, will show you a lot of information here. You don't even have to go in detail of this, but you can just look into here. So what actually it contains. Okay, this is what the features and what the core features, additional features it contains in SRS. Okay, but normally this is for more for a hardware related point of view. Okay, and for example, look at this. This is a server. How many devices it are connected to? How many mobile devices it are connected to? All this information is actually in the system requirement specification. Okay, system required specification. So that's about the SRS. And so normally you may not have access to SRS, but not necessarily. I know based on the project, whatever the project is, it's based on that. Next, you have PDM, that is physical data model. Let's do this. So this contains, so physical data model contains information about the tables, right? It contains information about the tables. So what is the primary key? What is the candidate key? All those things. Okay, so let's see. Here you see this. So this is all the information here. What information about the table? It contains information about the table, which is linking to another table, which is how it is. Is it a snowflake? Is it a star schema, or snowflake schema, or galaxy schema? Based on all those things, it contains into this. And there is something called ER diagram too. This entity relationship diagram, and that's not here. So that is different. You see this. This is similar to ER diagram. So ER diagram, ER diagram is pretty big. The reason, because if you're working on ETL process, okay, then you would be having a lot of things going on. Okay, so it's not just simple just put it into one page, because you need to know a lot of things when you're doing migration projects, or if you are dealing with OLAP database, OLTP database, and if you are keying out jobs and a lot of information there, so you need to know all this. Okay, so this is it's not so simple just to put in one page. It's like big, you need to coordinate with database administrator and as well as the architect people to get information of ER diagram. Okay, entity relationship diagram. So why do you need ER diagram? So that's very important thing when you start writing your test cases, because you need to understand what is primary key for that table, what is foreign key, if there is any natural key, candidate key, and so on, because you are filtering your data based on your transformation logic specified in the mapping document. So that's the reason you need to know the ER diagram. Okay, without ER diagram, it will be really, really hard, but you can still make it out in mapping document. Mapping document doesn't have all the information that is required actually. Okay, so but this is a PDM, physical data model. It contains information about the tables. There is one more thing called logical data model. So this logical data modeling document is, this is also contains information about the views. View is a logical entity, right? View is a logical entity, and it contains information about the views. Okay, so how we are studying the views, how we are modifying the views, so on. So based on the project, this is designed, and then we have the HLD. So let's talk about this HLD. So HLD is high-level document. So high-level document is, normally it contains the call flows. Okay, so it contains, normally, let's say if you're, okay, so let's say you're, let's take an example here. Okay, so let's say you're working in a project and you're working on IDR, right? IVR. So IVR is interactive voice response. Okay, for example, for this is, let's say you want to call Bank of America. Okay, you want to call Bank of America, and there's the number, right? 1-800 number, and you just dial that. And the moment you dial that, you're not really getting a customer response, right? You're not getting customer response. You have to go through this automation process, right? Now that's called web services in IT. Okay, so it's a web services that runs through automated process. Okay. Now once that you go through it, you enter some information like what is your date of birth, what is your SSN, last 4 digit of SSN, what is your mobile number, what is the account number, so on. Once you put all that information, once it verifies the information, then it goes to customer care, and it takes almost, for me it took like almost 1 hour to just go through that IDR and go use. So it's a lot of. Okay, so that design should be very should be good to have that. But thing is, that is called IDR. So that's the way you present in the document is called call flows. Okay, because if you enter some wrong information, it goes to a different route. It asks for some other information. If you enter correct information, it goes to a different route. If you don't enter both, then it has also another route. So that's how, if you put all those things in this document, that's called high level document. Okay, so that's the call flows. Normally, the flow chart. You know the flow chart, right? Start. You have the start loop, and then you have this rectangular box, decision box, the rhombus box, all those things. So once you put into that into the paper, that's how it looks. But when you are doing in the practical way, it's like calling the Bank of America through IVR. Okay, so that's the practical way. And if you're doing in paper, if you're putting down in the paper, that's you use the flow chart. Okay, that's called high level document, high level design document. Then you have TDD, technical design document. Technical design document is like, let's say you're running a job, so you understand what jobs, right? Let's say if you're in ETL process, okay, there are several tools. Okay, there's the autosys, there is a title. Okay, there's a lot of tools here. So why do we need that tool? So let's say if you want to move the code from dev environment to test environment, from test environment to production environment. Now, you cannot just copy paste, don't think, okay, it's very easy, just copy and paste. That doesn't work that way. There's a lot of millions of data, this GBs of data that has to move from one server to another server. You cannot expect, no, I'll just copy and paste. That doesn't happen. Okay, so don't even think of that, of doing that. Okay, so I'll just copy and paste it, that's it. That doesn't happen because you're dealing with millions of data and a lot of GBs of data, and so that's a really tricky part when doing your ETL process. So that's where you use this tool, Autosys. There's a tool for that. What it does, it has scripting, a lot of scripting like SQL. There is a SQL, and shell scripting. Then you have shell scripting when to kick out this job, when not to kick out. So what does it do is when you kick out, there's some instructions. When you kick out, that it pulls all the records. So there's a SQL for that. Okay, so it pulls all the records from the dev environment and puts into the test environment. Okay, now when do we have to take? Okay, when do we have to start this process? All this is designed in the put into TDD, technical design document. It's also called flow. It's also a flow chart. But here you need to understand what are the dependency jobs, what are independent jobs. That means after one job is kicked, you need to have to kick the other job, because if that is not done, then it will not move into the code, will not move into the test environment, or it screws the whole data. You need to do from scratch. So that's the complication. So that's all information is put into technical design document. Okay. So I don't think I have this document. Let's see here, technical design. Let's see. So this normally, just a block diagram. Normally it's a block diagram. So this is all okay, but what we'll be looking into it is the more into diagram part. What exactly how the diagram looks like. These guys don't have this. It's normally the block diagram. Let's see if we find here in this. Yeah, you can take this as just once you kicked off this, next we'll see if you have better option here. Yeah, this is kind of diagram, right? So this is first, when do we need to kick out, and what is independent and what is the dependent. This is not exactly that diagram, but this shows some idea of what you're trying to do in this. So basically it's a block diagram, when the job have to be kicked on. So this is how it looks like. Okay, first let's say you have kicked out this job. That means this will run here. This all the three jobs will be running, and after clicking this, you need to look at it, which other dependency is there on this all job, so on and so forth. Okay, so this is how normally a technical design document contains. Okay. Okay. Let's go to the next one. So STM is source to target mapping document. Okay. So let's look into it. So let's see what is STM. Let's get an idea of this. This is a good. Okay, good. This is good. Now, now you know what? This is STM. Okay, source to target mapping document. What does it contains? It contains information about the source and the target. Okay. Now it contains a lot of information. Okay. So let's see here. What is it? So this is BDW. BDW means it's business data warehouse. Okay. It's EDW and BDW. BDW is business data warehouse. EDW is enterprise data warehouse. Okay. Um, so no, so this is the target column name. Okay, so these are the column names here. Okay, address ID, party ID, no, all these are column names. Okay, and what is this column data type? So if you also want to understand what is the data type of that particular column. It's integer or varchar or date function. Okay, all this. And BDW target PK. PK is primary key. Okay, so so is it yes, yes, yes? So here, if you see this, primary key is supposed to be one, right? Primary key cannot be more because the primary key is unique and not null, right? It should be unique. But here you see this, there are many unique values. That means this shows as composite primary key. Okay, you have many more primary keys. You can maintain, I think, at max 24. That is long back. I think it was 2000, 2013 or 2014. Now I think increase that, but at that time it was you can maintain 24 primary keys in one table. That's called composite primary key. Okay, that means this is a composite primary key. You have to include all the primary keys when you're writing a SQL. And this is reference table. Okay, now this was all about target. Now let's talk about the source. Source, here you have source field name, that means column, source data type, and source. Okay, so this is a transformation logic here. Okay, now this transformation logic, normally you do logic to target table, but here if you see in this scenario, you also can do in source. So normally it's not really in the source, it's in staging area. Okay, just say it's source, yeah, that's fine, but it's a part of that source, so that this is called say staging area. Okay, so this is source transformation logic, and then you have this version, and this also has this own primary key, and it's if it is OADP, it's called natural key, and so all of this thing. So it contains. So this is called mapping document, STM, source to target mapping document. What is it contains? It contains all the information required to start your test cases, such as target column, target data type. What is the primary key, source column, source data type, and transformation logic. Okay, so that's STM. Any questions so far? So far, anyone has any questions in these documents? So you can look, you can look into these documents. I'll be giving you access by today. Okay, people who are having other than Gmail, Hotmail, or Yahoo, they can view this URL. I'll be giving you URL directly. so that you can view this without email ID. So that should be good for you. Okay, so let's move to the next one then. Let's talk about this test plan document. Okay, so test plan document is a high-level document prepared by the QA lead. Okay, now if you sometimes you might ask on your boss, I just start writing a test plan document. Now you cannot directly say that no, it's not my job, it's QA lead. No, you cannot say that. You need to work. You need to collaborate with your lead, and it's because your job is in test plan to give your inputs. Okay, although you are not going to prepare everything in this document, but you are supposed to give inputs like such as what does it contains. It contains test items, features to be tested, features not to be tested, what is the approach, testing task, and so on. Let's look into this. Let's look at this document here pretty quick. Okay, so this is how this document contains. It contains here who is implemented and who is the revision. Okay, and who is the author of this document? So author of the document is QA lead normally, and this is all the index part where see here is the thing what your type of testing you're doing, and what you're not supposed to do, what you're supposed to do, how this information is in this document. Okay, what are the items to be tested? What is the description? When it's going to be tested? Okay, what is the fail criteria for each and every testing? Right, we are doing a lot of testing here, right? Functional testing, integration testing, okay, performance testing. So for everything, there is information who is going to test and what are things to be tested. Okay, so this is called test plan document. Okay, this is. And then let's go to the next one. There's something called test strategy document. Okay, what is this test strategy? It contains information about test levels, roles and responsibilities, environment requirements, testing tools, risk and mitigations. Okay, why don't we look into this? Let's see here. Let's see the document here. Okay, we'll get a better idea. So this is an example of test strategy document. Okay, again the similar way it contains who's a document control, change control, all this will be there by default. Okay, here you go. This is what we were talking about. Okay, we are talking about this index, all this, and this contains all the information. How are we going to do this, and what is the precautions we are taking? What is the risk we are going to? What if it is not tested properly? What if how we are moving? So all this information is contains in this strategy. Okay, so normally in the work, they this plan and this strategy they take it one. So don't argue with them. This is the different. This is the technically they are different, two different things. But you don't have to make them understand. You don't argue with them that this strategy is different, this plan is different. They're saying test plan to test strategy to test plan. Just go with the flow because But if you're doing technical, more into technical, then you find it's a different because test plan is test plan is more on the approach point of view, and test strategy is a strategical point of view. How if it is not tested, how are you going to move it? How we are going to solve it? So that kind of things it contains in the test strategy. But in test plan is just a plan. Now it doesn't say if you fail something, how are you going to proceed? But there will be nothing in the test plan because it's just a planning, but it's not about talking about strategy, right? The strategical part will be in the test strategy document. Okay, so that's the reason. This technically these two things are different, but don't worry about it. If the work at the workplace they say they both are same, we don't use this, we don't. So don't worry about it. Just go with the flow. Okay, don't argue with them that these two things are different. Okay, let's go to the next one. That is test cases. Okay, we know the test cases. We have written test cases. So what does it contain? Test case is a high-level document prepared by a QA analyst. And what does it contain? It contains test case ID, objective, steps to perform, expected result, pass, fail, criteria, and comment. Okay, this is what test case contains. Okay, you have seen this test case, right? We have prepared the rally, so there's the same thing what is here, but here you need to be in detail when explaining. Okay, so that's the reason you need to come up with this. What are the things you do in the test cases? That is test case ID, objective, steps to perform, expected result, pass, fail, and comment. So let's see here. So we already done this. Just showing you to better idea. So here you see this. So this is the test case. The same thing what I'm explaining. Okay, so this is the test case. This is what we have written. Okay. Okay. Now let's go to the next one. Migration document. So what is this migration document exactly? So this migration document contains information about the project migration. Okay. Let's say let's take an example. Let's say there is a Teradata and there is an Oracle. Now they are migrating that whole Teradata. No, whole the Teradata into Oracle. Now, so when you're doing that, it's a lot of things, right? It's not just simple, okay, just go and do it, just migration over. No, it doesn't happen that way. Because a lot of millions of data, the source are too many, there's a source coming from IBM, there's source from Java files, .txt files, third-party vendors, a lot of things are happening there, so you cannot just move just like that. Now, the queries written in Teradata is different, the queries written in Oracle is different. Okay, so you need this document, a strong document which shows information like how are we going to migrate it and what the resources we require for this, what are the information we will be proceeding with this. So that's the reason you need this migration document. And the reason you need more because let's say somebody, some senior guy who is working on this and he knows a lot of Oracle, he knows a lot of Teradata, and he knows, how to handle those data and he left the job. Okay, now he was a senior guy. You know what? He was managing everything. He knows a lot of things about Teradata, and he left the job. And he left the job now. There's a lot of chaos there, right? How they want to hire a new guy, but new guy, how is supposed to do? Because the way project is design is different. Even though if he knows everything, it cannot. This takes time to get into the system and get understand what is the thing. That's the major important reason for having this document, migration document. The new guy comes up and he shows up, so you can understand what's going on and what next to do. Okay, so that's why you need migration document here. If the senior guy left, so there's a really problem out there. Okay, they cannot figure it out what to do and what not to do. So although these documents are really slowly getting outdated, but you know what, we cannot really eliminate everything because in the agile methodology, you still need the documents because, as I told you, right, if senior guy leaves the job, then it's really a problem for the company to, cope up with that. Okay. Okay. So let's go to any questions so far. Any questions in all these documents? So we discussed a lot of documents here. Okay. If you have any questions, can reach out to me, or I'll be giving you access so you can have this. You can look in this document. I would certainly recommend you to look at this document. How this look and feel. How the documents looks like. How they're designed. Okay. So that those kind of things you need to look into this. Okay. So okay. So let's go to the next one. SDLC process. Okay, SDLC is like software development lifecycle. Let's go pretty quick there. Okay, so what is SDLC? It's a software development lifecycle. Okay, and what does it do? So it's actually again, this is a framework. Okay, it's a methodology. It's a framework for the process. What? Somebody in the previous class, somebody, they said to me, hey, I didn't get an access for SDLC. Okay, now you need to understand this is not a software. Okay, just because it's written software doesn't mean it's a software. It's actually the process. It's a it's a process layer by a management perspective. The management decides, are you supposed to go to the agile, or you have to go to waterfall, or you have to go to incremental SDLC, or helical model, so on and so forth. So it's up to the management who decides. But since we are part of the system, we need to know this. Okay, so let's see here pretty quick. Let's check it out. So this is something which it's not like access perspective. It's a process. Okay, it's a management perspective. Okay, so you really you don't have any access for this, but it's like you need to understand the process here. Okay, let's see here. So we can have this like 10 stages here. Okay, if you are good with it, you can go with the 10 stages. But here I'll stick with the 6 stages. Okay, we just talk about the 6 stages here. So here's the definition for it: a framework that describes the activities performed at each stage of a software development project. So that's called SDLC. Okay, a framework that describes the activities that are performed in each stage. Okay, is called SDLC. So let's quickly check here waterfall methodology. Okay, so here you can go if you're really good at it, you can quote all this 10 cycle here, but I'll stick to 6, only 6 cycles. We'll be good at 6. This is called requirement phase. So what happens in the requirement phase is, this is a job of a business analyst or product owner. Okay, we'll talk about this waterfall. So business analyst. So business analyst, takes all the requirements from the, coordinates with the developer, coordinates with the tester, coordinates with the manager, and collects all the documents and understand how the business works, and put all this in the document. That's how FRD is prepared. That's how BRD is shown up. Okay, so that's how that's example of FRD. Functional requirement document is right. It starts from requirements. So that's how what happens in the requirements. It's the job of a business analyst. Next is the design process. So this is more a job of a architect guy here. Say, okay, this architect guy is working on it, and okay, so he looks into design perspective, like what's the data that what the data it should be there, and what are the columns to be available in it, and what's all information that is required. So this perspective, ETL perspective, okay, not just QA but also in the ETL. That's the job of a architect. And then you have implementation process. In this implementation, this is the job of a developer. Okay, and a developer starts coding in the implementation. You'll see this. Okay, this is good. It's good, and this is okay. This is will be in the development process. So job of a developer who codes it, who does the coding part. Test. So here the testing process is done by the QA process. Okay, this is done by the QA people, and this is where your application gets tested, and it moves into the production after this testing. Okay, installation. This is the job of a middleware team. Okay, so this installation is normally moving the code from test to production environment. It's called installation phase. Okay, so now a lot of people are involved here. This lead is involved. Your job as a QA is more of a coordination here. You need to coordinate a lot of things. Okay, how is the job going on? How is the main? How are you going to send the data? What is the data that has to be done? All those things. So coordination is very important for a QA point of view here. And the maintenance. So maintenance is a lot of things here. So once it's gone into production, you need to make sure there's no production issues. So senior QA or QA lead is responsible here to work on this. To work with the developer, because developer also is there and works with them. So if there is a production issue, what we are going to do, if you want to test in writing production, or we are moving the code into the test environment, or we don't have time for this, and all this happens in the maintenance environment. I'm sorry, maintenance stage. Okay, so So the question for you guys. So as a QA point of view, as a QA tester, right? Where does our job starts from? Can anyone answer? As a QA, where does your job starts from? Okay, anyone else? Okay, from the requirements. Anyone else? Okay, testing, implementation. Okay. Okay, so if you think our job starts from here, from let's say testing or implementation, so all these stages will be idle. So do you think, the client pays you for being idle? No, right? Nobody pays you to be idle. So our job starts right from the requirements. Okay, right from the requirements. Why? Because this is where you know you show up in the picture. Okay, you get involved in the meetings. Let's say they bought a document. Okay, they come up with a document saying that okay, this is the requirements, and you need to do brainstorming here. Here is the brainstorming session. Okay, that means let's say your lead says like how are we going to proceed with this? We are already blocked with various testing. Three environments for testing and all things are blocked and you're showing up a new requirement. How are we going to show up? How are you going to do this testing? So we need to create one more environment where we can so all these things are right. This is called brainstorming. Okay, and your job here is to involve in the brainstorming and also find out some issues in the requirements. There might be a lot of issues in the requirements too. Okay, this document, okay, for a, to start with, you may not find, but as a senior QA or, you're working from 1 2 years, and you know what, they might come up with requirements and you might find some issues with the requirements itself. No, this is not right. No, uh, this we have already done, and this is something which shows a lot of issues with this. So how are you going to proceed with that? Okay, so those kind of things you do all this in a requirement stage. Okay, so you are, whatever you are QA, you're a lead, you're a, developer. Your job starts right from the requirement phase. Okay, now what are we going to do in the design phase as a QA? In design phase, we will be working on documents. What documents? Test plan document, test strategy document, okay, and test cases. Okay, don't miss that. Okay, you will have test cases too. So all this we will be working on design, design phase. Okay, let's go to the next implementation. As a QA, what you will be doing here? Let's say you didn't have enough time of test plan and test strategy. We only created 2 documents. Here you'll be working on test cases. Okay. In the implementation phase, you'll be working on a lot of test cases. Okay. So what's the job in the test? Here is what we do is execution of the test cases. Okay, this is the only part we'll be doing execution. All writing test cases and all those things have been done in these 2 phases. Okay. Here you'll be executing the test cases. Now what you'll be doing in the installation as a QA? As a QA, you will be coordinating with the middleware team, coordinating with the developer, coordinating with the every business analyst. Maybe not too much, but you will be coordinating with the middleware team. Maintenance. In the maintenance phase, as a QA, it's more for a senior QA or lead. Okay, so if there is a production issue, how are you going to test it? Are you going to move this environment? Are you going to do in production environment? It's not really a good idea to test in production, or how are we going to do all those things? So all this will be done in the maintenance phase. Okay, so these are the six major phases, but as a QA, you'll be involved right from the start. Okay, that's requirement phase. Any questions so far? Okay, so let's move to the next pretty quick. So this has some advantages and disadvantages. Okay, so advantages is so one of the thing is if you think quality is more important than cost, then you go this waterfall methodology. Okay, when you think quality is more important than cost, then waterfall methodology is for you. Okay, if you think the other way, if cost is more important than quality, then you go to agile. Okay, either way, you're not the one who is making the choice. This is made by the management perspective. So really, it's not your option to make the choice. But you need to know this strength. Okay, so this is the strength of waterfall methodology. Okay, so let's go to the next one. So there's one more methodology, V-shaped methodology. Again, the phases remain same, but here the way you do the things is different. Here you're doing two things simultaneously. Okay, here your requirements planning and production operation, you're doing two things, and requirements, specification analysis, system acceptance testing. Okay, so you're doing the two different things in the same, so that's called V-shaped SDLC model. But the phases remain same. Okay, phases, whatever testing you're doing, you'll be doing all this here itself. Okay, so here they changed implementation. There was the implementation here, they're calling it coding, same thing. Okay. And it has its own advantages and disadvantages. Let's go to the next one. So already, so we'll discuss on this. Okay, so rapid application model is more of a agile perspective. So agile is pretty broad. Okay, so it's pretty broad. So if somebody says you're working in agile, that's really okay, agile. So it's nothing to do because it has so many different phases. I mean, different submodules. Like it has Scrum, agile has Scrum. It has already rapid application management, rapid application model, and then you have this Kanban. Okay, there's Kanban, and there is one more. There's one more thing actually. So there are a lot of things in agile. Okay, these are all the part of the agile. Okay, so here incremental SDLC model. Okay, so here this is same SDLC, but here you do is verification and validation. Okay, here you do this verification and validation, but the phases also again remain same, but but you do extra here is verification and validation. Okay, so here, let's go to here. This is again the spiral. So these are what we are talking. All this is waterfall methodologies. I mean, SDLC model. Okay, waterfall is waterfall is derived from SDLC. All these are derived from SDLC. Okay, that's why different name. But the process remains same. Okay, spiral SDLC here. So in this spiral, right, you have these four quadrants. Here, the first quadrant is objectives. Second. The result is third is develop, fourth is plan, next phases, and you keep moving moving the spirally. Okay, first prototype, then concept, then requirements, then design, then implement. So you're actually moving in spiral way. So that's why this is called as spiral SDLC model. Okay, let's go to the next one. So agile, we talk about this agile, okay. Monday, it will be, yeah, it's Monday. And we take core class, we'll start about this, whatever terminologies and what we do in agile, so all those things we'll we'll talk on Monday. So as I said, right, agile is pretty broad. Okay, it's just a name. You have lot of sub features. Here you see this. It's ADS, ASD, agile adaptive software developments. Then you have extreme programming. Okay, extreme programming is also part of the agile Scrum, and this is also called Kanban. So all this, is a different way of doing the same process, a different procedure. Okay, but it still comes under agile. So it's up to the project how they want to implement. It's not necessary this all of this should be implemented in one project. You might use only a Scrum in some project, and in some project you might use machine programming. Okay, so we'll discuss about Scrum. No, Monday we'll talk about the Scrum. Scrum is more famous because it's more ceremonial kind of thing. A lot of people gather, a lot of meetings. You have other methodologies. Other methodologies don't have that much of meetings. You just do your work simply and just attend a phone call, weekly phone call, and that should be good. But Scrum is more interactive and more into dynamic way of doing the work. Okay? You can refer this document. This document is there in the Google Drive. Once you give the access, you can refer to this. Okay, let's go to the next topic pretty quick here. So let's talk about the STLC, software testing lifecycle. Okay, so what you do in testing lifecycle here? You have test plan preparation, test case design. So we have done all this, right? We have talked about the test plan and test case design. So that's what we'll be doing here. See this test case. We have written this test case, right? So this is what it means by test case design. Okay, test execution and test log preparation. Of course, we have done that too. Somebody deleted my execution, so I'll be using the previous one. This was August. I hope August one is not deleted. Okay. Here you go. This the execution part. This is called execution, and the log whatever you put in this log. Okay, so that's called logs. Okay, this is the information about the execution. Is it passed? Is it failed? Okay, so that's called test execution. Okay, and test log preparation. Defect tracking. Let's say you have opened this defect, right? Let's say you have opened this defects. You need to track that because you have this number, defect number, say D409, D408. Okay, you want to track it here. Okay, so here you see this, and you can put the name 409. Okay, and here you go. So this is called defect tracking system. And test report preparation, of course, we have done that too. Okay, you have these reports. We go into the reports and we will just see here the graphs which is already generated for you. You need not draw any graphs. Okay, this is automatically made for you based on your user story, based on your test cases, and all this is prepared for you. Okay, so this is called test report preparation. This is a part of the testing life cycle. Okay, so I hope you. So if you understand this, rally completely, so I think you'll be, you'll be understand better in testing life cycle. Okay, so that means test plan preparation, test case design. We already done that. We have not done test plan preparation, so we'll go to that maybe most probably tomorrow. Yes, I got tomorrow. But once we talk about Jira, we'll be talking about test plan. Okay, so we'll just I'll give you homework on that. So test case design, we have already done that. Okay, test execution and log preparation and defect tracking test report. These are the parts of testing lifecycle. Okay. So, any questions so far? So here we know these roles and responsibilities, right? So this is how it goes. You will be QA tester, QA analyst. Okay. So
Do you have any notes Any notes besides this video too?
Yeah, you can take the slide. So the slide is okay for you?
It's okay, but we want to this is printable or not?
You want to print it? Yeah, you can print it. So print is fine. But yeah, so the slides, let me tell you where is this located. Okay, go to 26th directory. I'll be giving you access to Google Drive. Okay, once you get it, oops, modification. Okay,
Like we got the class for the Oracle and Linux. We got this one note and video both.
right. So here you have all this information. We get this all the slides. Okay, whatever I'm saying to you, whatever slides. Let's see. It is the third. So here you see this. You have this. So once I give you access for this Google Drive, you can able to look into it.
Right.
Okay.
Okay. Thank you.
Wow. Somebody changes. Okay. So let's go to this. Okay, so here is let's talk about this hierarchy. Okay, hierarchy is now once you are a QA, you're a QA, and your boss will be test manager. Okay, so test manager, and okay, below that, your QA will be QA lead. Okay, he is the one who will be looking into your test plan, review your and monitor your issues, monitor tracking all these things. He will be monitoring you and guiding you what to do and what not to do. And above is test manager. Okay, and above test manager is a test director. Okay, who monitors all these managers. Okay, and so that is the hierarchy. And then you have this developer. The developer goes a similar fashion. Here, developer might have more, more roles because there will be a developer, developer who codes it. Then you have dev lead who works on that, and then you have a dev architect, architect who also works, and then for all this managing, there's a dev manager, and the boss of this manager is test director. Oh, I'm sorry, dev director, okay, development director. So that's how the roles and responsibilities goes. Okay, so you have, you'll be having access all this, okay, by today, okay. And if you want to, let me know. You can also, I also show you where exactly it's located. It's 26th directory number in this, and by today I'll be giving you access to this. Okay, so let's go to pretty quick. The one more is called bug life cycle or defect life cycle. Here we'll see, and you know what, we actually done this. We have done this before, and but let's see in a theoretical point how did we do this. Okay, so here's the thing. Now, when you open a defect new, it shows us new. Okay, let's show you how did we do this. Okay, let's go to here. You see this defect. We talked about this defect. There you go. So what we are talking so far in this defect life cycle is the status of that defect. Okay, you see this. Once you do this, it's in submitted. Okay, and then open, fixed, close. Okay, so that's what here we are talking about. Once it's new, okay, it's goes new, and then it's once you change the process, to change the status to open, then you assign to developer, the respective developer, then it goes assign. And once the developer fixes it, there should be one more option that's fixed. Here they don't have it. Once you fix it, they will revert you back and say, then you need to test it. And then once you test it, verify it, and then you close the defect. Okay. Now that's one flow. But once in the assign status, let's say you didn't, it was not fixed. Okay, you're not satisfied with the fix. Then you reopen the defect. Okay. But this time, if you reopen it, you need to coordinate lots to the developer because it will be get straight away rejected if you don't coordinate. So coordination is very important because you are reopening the same defect which was actually fixed, well, that's really not a good sign of reopening it. But if you are reopening it, you need to talk to the developer, or else it gets rejected simply. Okay, so reopen it again, assign it, or maybe you're assigning to different guy because it's not responsible guy. Okay, something like that. So again, once you go to, there are two options here. They can reject your defect or they can defer your defect. Defer in sense it goes to the next release. That means they don't have time to work on your defect and they'll be deferring the defect. That's called defer. Okay, so all this is actually shown here. So this is here you have a few options though, but this is how rotation takes place from developer to tester, and or if you are assigning to some other guy, some architect guy, or some other developer, then this is the rotation. That's called defect life cycle. Okay. Any questions so far?
Yeah, I had a question. So those videos that we have over there in our email will not get deleted, right? Like we can access to those videos as much as we can, and like how long it will be there in the YouTube? Like will it get deleted?
So yeah, that's a very good question. So I would recommend to you to download it. So most probably it will not get deleted. Okay, mostly it will not get deleted because it's there from 7 months, 8 months. The previous videos are there. But I would recommend you to download it to for a safe side, because if we don't know, right, what happens. So it's a better idea. Even if YouTube goes offline or somebody else delete my video, I don't know. So that scenario, I recommend to download it. Otherwise, yes, it will be there YouTube until YouTube is there. So
All right, thank you.
okay, yeah, that's a really good point. You need to always think about it, because I recommend, strongly recommend to download it, because nobody knows what happens next, right? If somebody deletes it, it might be gone, and I don't even know. Okay, who deleted a lot of no. So if you see, there is an if you want to download it, you can download from this. This is the URL. Just put that video, video URL. So how long is Google? So here, if you this is one good site. If you want to download it, just put in the URL there. Let's try Firefox. Okay, good. So here, what happens, right? If you have my YouTube URL, just put that YouTube URL here and download it. That's it. It's simple. Okay, because I don't think YouTube has its download option. If it has, that's good. If it doesn't have, then just put that URL, whatever classes you're looking for, and download it. And it's better to have yourself for the safe side. Okay, you never know what happens next. Okay. So, any more questions?
So yeah, because I missed some classes in the beginning, so I could not do the homeworks that you gave to me. So does that matter? Like I can try that later, right?
Yeah, you can try it later and just make sure you do it at least, it's for yourself actually, just make sure you complete it at one point of time, because, you have to understand, right? So what's going on and what's happening. So, yeah. Yeah.
Yeah, it's because like yeah, I feel like I'm lost because everything was coming at once. So
Right.
um, I'm having trouble in my computer also. So I'm just making it. I'm just figuring out how should I do it. So yeah, thank you so much for that.
Yeah, just just try to complete it whenever you're free, and just so it's for you actually. It's for you because you'll get some knowledge, and you'll be understanding what's going on, because these are all classes are interdependent, right? So that's what, if you come in between like fourth class, you start with fourth class, you will not able to understand. So what is rally, what's going on, what is PFS, okay? So that's the reason you need to do from scratch and understand and what's going. So that's the reason give homework so that you get more knowledge on that.
Yeah, so I need to go over the first class, like every videos that you have. Like I need to go there because I didn't get much time to go there. I'll get there and I'll get your all videos and I'll do it. Thank you.
Yeah. Okay. Good. Any more questions? So yeah, I'll be giving you one more homework. Also mostly today, if you'll be having some time, you can do it. Okay. Even if you're not complete, make sure you complete by 20 seconds. 2 weeks. It's up to you. So how you want to do it, but make sure you do it. Okay. Okay, so if no one has any questions, can we close this class for today? Okay, so Monday we'll be discussing about agile. So we'll talk about this agile on Monday. Okay, thank you guys.